Welcome to Master Talker online class. If today is your first day of watching our video, please consider subscribing. Okay, in today's video we'll be talking about a binary operation. Okay, binary operation is simply the rule of combining any two elements of a given non-empty set. Okay, and it is defined and it is denoted mathematically by any sign at all. Sometimes we use this. Okay, now by means two. Okay, when you have two non-empty sets, then you want to operate it with a particular operation. Okay, that operation is called the binary operation. So it must be at least two things that you want to operate. So sometimes we call this one of the operation. Sometimes we use this as the operation. Sometimes we use something like dot with a circle. Sometimes we use this, for example. Sometimes we use as times. Sometimes we use this. Okay, and sometimes we use this etc. We can use anything as the operation, and anything you use, you must define it. Okay, you must define it. So let's define operation. Defined operation. Defined operation. Now if we say that they say this is the basic rule to be followed in a given problem. Okay, defined operation is the basic rule to be followed in a given problem, and that is not what I'm interested in. I'm not interested in the definition. I'm interested in finding the solution. Okay, so we have that A operates B, and they say that is the same as A times B. Okay, then this is A plus B, and A is A minus B. Okay, so these are the basic operation. Okay, you can equally have, it mustn't be something like this. It can be 3 and this. It can be maybe 7 and 7, like something like this. It can be anything, but just know that they will give you the formula, that when this operate this, that this is the formula. Then you will not ask to find a particular thing. Okay, so they can say that when A operates at B, that the formula is maybe 7 minus A over 2B, something like this. Okay, so they will just give you the formula, and then they can ask you to find anything at all. But before that, let's talk about some properties of binary operation. Some properties of binary operation. Properties of binary operation. Okay, properties of binary operation. Now, the first property we are going to talk about is the closure property. The closure property. The closure property. And the closure property says that a set a set D is said to be closed. Okay, is said to be closed under the binary operation, star. Okay, on if for all A operates in B is equal to C, and that C is equal to C such that A, B, and C are still elements of D. This is a very long story to tell, but what do we mean by that? We mean by that something is closed. Closure, the first one we're talking about is closure. Okay, now something is closed when if A operates on B, okay, and you get another thing C, and that A and B and the c you got are all in that set. Okay, then we'll now say that what, that this set is closed under the operation this. Okay, so let me give you an example to that. Example, if we say that if you are talking about a set of real number, okay, a set of real number is closed under the binary operation addition. What do I mean by that? If I say that a plus b, okay, like this, a plus b is equal to a plus b like this, okay, which is equal to c, and I say that a, b and c, if I say that a, b are elements of what? Real number. Okay, I got a and b from elements of real number. If I add both of them, okay, can I get another element of a real number? If yes, then we'll now say that what, real numbers are closed under the operation addition. Are you getting that now? They are closed under what? Addition. So for example, natural number, if I say that look at natural number, for instance, that a and b are elements of a natural number, and I have that a operates on b to be a plus b. Okay, now is a plus b still an element, a natural number? Is a plus b still an element of a natural number? Yes. If you add any two natural number, you will still get a natural number, so it is closed under addition. But look at subtraction. If I say that a and b, okay, a operates on b such that a minus b. Okay, now is natural number closed under subtraction? Is it closed under subtraction? It's not closed under subtraction. Why? Because if that is a and b being an element of a natural number, once you can get one that does not work, then it will not work. Okay, what do we mean by that? Choose any two natural numbers you know. 3 is a natural number and 5 is a natural number. Let me say that a is what? 3, and then operate on b, which is 5, which will give you 3 minus 5. If you look at 3 minus 5 will give you what? Minus 2. And minus 2, which is the answer, is not an element of a natural number. So therefore, natural numbers are not closed under addition and under subtraction. Okay, they are not closed under subtraction. Now, are they closed under multiplication? Yes. If you multiply any two natural number, you will still get a natural number. So they are closed under multiplication. Now, are they closed under division? No. Why? Because if I say that a operates on b to be what? A over b, and a and b are elements of a real number. Now, is a and b closed under natural number? We are still talking about natural number. Is a and b closed under the natural number? Let's check out if they are closed. Now, let me choose any natural number. A is what? 2, and then b is what? Maybe 5, for instance. Now, I have 2 operates on 5. What do we have? 2 over 5. And is 2 over 5 an element of the natural number? No, it's not an element of the natural number. Therefore, natural numbers are not closed under division. Okay, so that is what we mean by closure. Closure means when you operate them, you will still get the answer as an element of that set you are talking about. That is about closure. I hope you understand that. Okay, so the next one is what? Commutative property. We are talking about closure. Commutative property. Now, commutative property means that when x operates on y, it must give it the same as y operating on x. Okay, that is what we mean by commutativity. Okay, so an example of that is you can use any set you like. Let me say a set of integers. Are the set of integers commutative under the operation under addition? Let us check that. If I say that, let me choose any natural number I know. Let me say that x is equal to, I'm talking about integer, minus 2, and then y is equal to maybe 5. if I say that minus 2 operates on 5, for instance, as, okay, the operation here, we want to use addition, that x operates on y means x plus y. Okay, so let us check, and then y operates on x means y plus x. So let us now check, this operates on this, is it the same thing as this operates on this? Are they the same thing? So let's check, minus 2 plus 5, is it the same thing as saying 5 plus minus 2? Are they the same thing? Minus 2 plus 5 will give you 3. Why this one will still give you 3? Now, since they are the same thing, we can conclude that what? Now, I'm just giving a simple example. I'm just giving number for you to understand. But in proving it, we don't use number, because any other thing can fail. We use what? We use alphabet. Okay, we use alphabet. So if we say that x that this is given as this as y plus x, and the x and y are elements of the natural number, for instance, or integer or anything. So if you don't know all these things I'm calling the set of number system, so you can watch my video on number system. The major number system we have are what? The natural numbers, the integers, the rational numbers, the real numbers, and then the complex numbers. Okay, these are the 5 major number systems we have. So you need to go and look at it for you to really understand this binary operation. Okay, so can we say that natural numbers are commutative, are additive commutative, or are commutative under addition? What do I mean by that? That if x operates on y to mean that x plus y, and they say that x and y are elements of a natural number. Now y operates on x as what? Y plus x. Are they equal? That's what we are trying to say. That is x operating on y the same thing as y operating on x for all x and y being an element of that natural number? Is it possible? Like for any natural number you bring together, then operate it using addition, that the other one going first and the other one going first, will they give you the same thing? That's what we mean by what? By commutativity. And you can check it for any operation at all. It may not necessarily be only addition, subtraction, blah blah blah. They can give you, for example, watch. They can say, look at an example. They will say that that x plus y is equal to, maybe they will give you a formula 2x minus 3y. Okay, then I say that x and y are maybe elements of the real number, and then I say that we should prove that x that x and y are commutative under the operation what? Star. Let me use star for instance. Okay, under the operation star. So let's prove that. How do you prove that? Let us check. They say that x star y is the same thing as saying 2x minus 3y. Okay, now y star x is the same as saying 2y minus 3x. Okay, because this x is because it's the first one. Okay, x being the first one will be here, y being the second one will be here. So in the next one now, y is the first one, it will not be here, and then x the second one will not be here. So are they equal? Is x star y the same thing as y star x? Are they the same? No, they are not the same. Therefore we conclude that what? That this operation, that this function is not commutative under the operation star, under this operation. So that is what we mean by that. That's what we mean by commutativity. So the next one we'll look at is associative. Now, associative property involves 3. Okay, associative property involves 3. Look at what we mean by associativity. That if x operates on y, okay, and then operates on z, operates on Z, is it the same thing as saying X staying alone? Sorry, X operating on Y operation Z. That is what we mean by associativity. Once if you operate this one, use the answer to operate this one, is equal to you operating this one first, using the answer to operate this one. If they are the same, we now say that it what? It is associative. Okay, it is associative. So an example, you can use anything as an example. For example, now if you say 2 times 3 times 5, is it the same thing as saying 2 times 3 times 5? Are they the same? If the results are the same, we will just conclude that what? That this equation or this function is what? Is commutative. Sorry, is associative. Okay, so the next one we'll talk about is identity property. That is number 4. Number 3. Number 4. Identity property. Identity property. Identity property is saying that what? That if A operates on any identity element, that you will still get that element. Okay, now you need to note, please note that 1 is an identity element. 1 is an identity element in multiplication operation. What do I mean by that? I mean by that any element at all times 1 times is the operation, times 1 will give you that element. So we conclude that what? 1 is what? A multiplicative identity element. Okay, a multiplicative identity element. Then 0 is an additive identity element. Okay, 0. Another thing you need to note is that what? That 0 is an additive identity element. What do I mean by that? In operation of addition, any element plus 0 will still give you back that element. So that's why we say that 0 is what? An additive identity element. Okay, so that is that. Sometimes they can ask you to find the identity element of a particular operation. So you will still get to that. Let's just list the properties. The next one, number 5, inverse property. Inverse property. Now for inverse property, this one says that what? That if you operate, A operates by its inverse, okay, that you will get an identity element. Okay, that if A operates its inverse, that you are getting an identity element. So what do we mean by that? We will say that now what do you think is the inverse of multiplication? Whatever you operate on its inverse and get the identity element, you conclude that that thing is what? Is an inverse of that particular thing. For example, you know that A times 1 over A will give you an identity element, and it's giving me an identity element 1. Okay, so therefore 1 over A is the inverse of A in what? Multiplication. But look at another one. A plus minus A is equal to what? It will give me an identity element 0. Okay, so therefore minus A is the inverse of what? This element. Okay, so that is how to get that. So number 6 said distributive property, which is the last one. Distributive property. Now for distributive property, it works with 3. Okay, 3. Now the difference between associative is the same operation goes there, but in this one different operation. For example, A operates on B, okay, A operates on B, operates, let me use another thing, dot operates on C, okay. Is it the same thing as saying this and this? A operates on B, dot this one and this one. A operates on what? On C. So once you have this type of thing, you conclude that it is what? It is it is distributive. Or you can have it this way: A operates on B like this, then operates on C. It's same as what? These two work on this first. That is A operates on C star. A operates on what? Sorry, B operates on C. So that is what we know as what? As distributive. So now we said that multiplication is distributive, okay, over addition. Now if this works out, we say that what? This one is distributive over this one, okay, this one is distributive over this one. So we note that what? Note that addition is distributive. Sorry, multiplication is distributive over addition. Multiplication is distributive over addition. Please, you need to know that. Now what do I mean by that? Look at that. You have A times B plus C. You can conclude that it is what? A times B then plus A times C is correct. But addition is not distributive over multiplication. You can never say that A plus B times C is the same as saying A plus B then times A plus C. God forbid. It can never work. Okay? It can never work. If you like, check it. Let us check if it is true. Let's say that A is equal to 2, B is equal to 1, and C is equal to 3. For instance, let us check it out. 2 plus 1 times 3. Is it something as saying 2 plus 1 times 2 plus 3? Let us check. 2 times, this is 2 plus 3. Is it the same thing as saying this plus this is 2 times this plus this is 5? This plus this is giving me 5, but this plus this time this is giving me 10. So it's not the same thing, okay? But if you try it in the first one, you see that they are the same. So we conclude that what? That multiplication is distributive over addition, but addition is not distributive over multiplication. Okay, that is that. So the next thing we look at, let's solve some questions. They say no, let's solve some questions that will help us to understand this perfectly. So the major things they will ask you in exam, in fact most of the time they do ask all these laws, okay, all these properties, so you need to know them. The first one is the closure. Closure means if I operate both of us, if we are coming from the same family and they join us together, the answer we get will still come from that same family. That is called closure. The next one is commutativity. Commutativity means if I operate on you, is it the same thing as you operating on me? That is commutativity. The next one is associative. Associative is three people that if we use the same thing to work on two of us, the answer to you, okay, that is let me say A, B and C. Associativity said if both of us work together before we carry the answer and work on you, the same operation, is it the same thing as saying that both of you will work first before you people will now come and work on me? So is it the same thing, the same operation? So that is what we call associativity, okay? Then the next one is identity. Identity means that if I operate on you and I get myself back, okay, and I get myself back, then automatically you are an identity element, okay? If I operate on you and I get myself back, then you are an identity element. then you need to note that what 1 is what a multiplicative identity element, because 1 times anything is the same thing, and 0 is an additive identity element, because 0 plus anything is still 0. Okay, so the next one is inverse. Inverse said if I operate on u, I will get an identity element, that is inverse. Then you are the what? The inverse. So you need to know that if I operate on you and I get an identity element, then you are an inverse. So we say that 1 over a is what? Is multiplicative inverse. Okay, and the minus a is what? Additive inverse. Okay, additive inverse. So the next one is distributive. Distributive is saying if we are 3 like this, if we are 3, A, B and C, okay, and then I'm having an operation here with another different operation, that can we separate it? That's they say the way you will remember distributive is when you have something multiplying another thing that is added like this. Clear the bracket. Do you remember clear the bracket? This time this plus this time this. That is clear the bracket. So remember distributive by clear the bracket. Okay, so that is that. Now let's talk about non-tabular. Let's check the time before we continue. Okay, thank you very much for watching. We'll look at a non-tabular binary operation for more than one properties. Thank you very much. Please don't forget to like, share and subscribe. God bless you.